Hi guys, in this video we are going to learn about how to count the number of unique elements in a sorted array in an optimized manner. So what exactly the problem states is we have to find out the unique elements that are present inside a sorted array. That is, although if there are multiple occurrences of a particular element, we must consider only one occurrence of it. For example, 10 in this particular array, 10, 20, 20, 30, 30, 30, I have 10 occurring once, 20 occurring twice, and 30 occurring thrice. But we must only consider each element that occurs once in an array, means at least once in an array. That is, 10 occurs once, 20 also occurs once, at least once, and 30 also occurs at least once. So the number of unique elements that are present inside the array are 3. And for example, in the second example or the second test case, we are given that our array is constituted of 3 elements, that is 10, 10 and 10. So since all of them are same and there is 10 occurring multiple number of times, so there is only one unique element present, that is 10. So let's write a naive code for it. In this naive solution, we would be considering a temporary array where we would be storing our values that we are taking from the sorted array and which has occurred once, and we would be ignoring the further occurrences of that particular elements in that array in that particular original array, and we would be storing this in a temporary array. So in the temporary array, we would be storing only one occurrence of the particular elements that are present inside the array. So according to you, what must be the size of this temporary array? There could be a possibility that all the elements in a particular array are unique. So the maximum size of this particular temporary array must be equal to n. So let's write a particular function for it. So it is given by int, suppose count unique, and we are passing an array, integer array, as well as the length of the array, okay, as the parameters of this particular function. So int count unique has 2 parameters, that is int array as well as int n, which is the length of that particular array. Now we would be declaring a array which is equal to which has a size which is equal to the original array arr, that is arr. So int temp would have an initial size, would have a size of n, which is equal to the size of arr. Now the first element will always be an unique element, means the first element we would be always adding it to a temporary array because it does not have any occurrence of it previous to it. So the first element, temp 0, would be equal to arr of 0, right? So temp 0 would be equal to arr of 0. Now we have to consider we have to consider a variable which would be keeping in touch with the count of the number of unique elements, right? So let's keep a variable known as count. So let's keep a variable known as count. So here let's keep a variable as count. Count is equal to 1. Since already in our temporary array one element is present, therefore we are initializing our count value with 1. Now let's run our loop from the first and from the second index till the last, and let's see which are the elements that are occurring. So see, since this is a sorted array, so we just need to check for the last element of temp, and we need to check whether it is occurring again whether it is occurring in the add or not. If it is occurring in the add, then we must not include it in the temporary array. If it is occurring, then we must not include it in our temporary array. If it is not occurring, then only we must be adding it to our temporary array, and we must increase our count by 1. And the last index of the particular temporary array where the element is stored is represented by count minus 1. Since count is keeping the number of elements that are present, so if I subtract it subtracted by 1, so it would be giving me the 0 based index of that particular element in the temporary array. So what I am trying to say that, suppose I am iterating through the loop for int I is equal to 1 semicolon, I is less than n semicolon, I plus plus, if the element is not present inside, if the last element of the temporary array is not equal to the current element of the array, then I would be including it. See, this is because suppose I am at index 2. If I am at suppose index 1, I can see that the last element of my temporary array, so initially my temporary array would be looking like this: 10 dash 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 dash. I guess I put an extra dash here. Yeah, so this is it. So initially my temporary array would be looking like this, where I'm initializing the first value. This is my temp. So since I'm initializing the first value with the value equal to add, so it would be equal to 10. When I'm coming here, I'm seeing that I am having a value 20 here, but since it is not equal to 10, I can add it because it's a unique element now. So I would be adding it here, but in the next iteration, I am seeing I'm getting 20 again. When I'm checking it with the last element of my temporary array that is present, I am seeing that I have already 20 present, so I would be just ignoring this, right? So I would be ignoring this. This would be an E, yeah. So I would be just ignoring this. So if temp of count minus 1 is not equal to add of I, then I would be including it into my temp. So temp of count would be equal to now add of I, since it is a 0 based index, and so I would be increasing my count by 1. So count plus plus count plus plus, and I would be closing my if, and so this would be my for loop, and I would be closing my for loop as well, and then I would be just return count. So this is how we would be counting the number of unique elements that are present inside my array. But in this particular code, we are using an auxiliary space of order of n, which is the temporary array that we are using in this particular case. Although so this would be my auxiliary space. Although the time complexity of this particular code is order of n, which is a linear time, and it is good, but we are also using an auxiliary space. So let's see whether we can try to solve this particular thing. And also, if somebody asks you what are the particular unique elements that are present inside the array, then we can just iterate till count, and we can print So this would be the end and my count would be pointing at 3. So these would be my unique elements that are present inside my sorted array. So this is how we can solve this particular code in order of n time complexity and order of n auxiliary space. So let's try to remove this order of n auxiliary space and try to solve it in a much easier manner using only the array that we are provided. That is, we would not be declaring another array and make changes in it. We would be just using this particular array only. Okay, that we are provided as our input. So in order to do that, we can keep a count, and so what I am trying to do here is, suppose I have 10, 20, 20, 30, 30, 30. Okay, so initially, since I am considering the first element, so the first element is always the first occurrence of that element. So always I can see that at least one element would be a unique element, because even all of the elements are same, there would be one occurrence of that element, that is, there would be one unique element present. That is, suppose in the second case there is 10 occurring 3 times. 10 is the unique element, that is, there is 1. So we would be initializing count by 1, and now we would be checking whether count minus 1 is equal to we would be starting our index as I, and we would be checking whether count minus 1 is equal to I or not, is equal to the element present at I and not. If it is not equal, then we would be increasing our count by 1 to 2, and we would be pointing it here, that is count minus 1 would now be pointing at 1 and my I would be here. Then I would be comparing, I would be seeing that it is same, so I would not be including it. Then I would be seeing here, and I would be seeing that they are not same. So what I would do, I would swap these particular values. So what would happen, that this would become 30 and this would become 20. Okay, so I got 10, 20, 30, right? Or instead of swapping, I can just assign the value of 20 as 30. So now my I is present here and it is same, so I would ignore it, and I'm in the last element, my I is same, so I would ignore it, and my count would be 3, right? Because of the 3 elements, I had forgot to increase the count in the previous example when it was compared with 30. So my count would be equal to 3. Now let's keep a count variable as 1. So int count is equal to 1. Okay, for int I is equal to 1 semicolon, I is less than n, I plus plus. So I'm just iterating through the entire array as I had said before. While iterating, I would be checking whether my element in the last in my count minus 1 is equal to the current element or not. If it is equal, then I would be ignoring it, and if it is not equal, I would be changing the value at count, and I would be increasing my count by 1. Okay, so if add of I is not equal to add of count minus 1, if add of I is not equal to add of count minus 1, then I would be changing the value of add of count by the value of add at ith index so array of I, and I would be also increasing my count by 1, so I would be increasing my count plus plus, and thus our iteration would be completed. So this is how we would be doing it, and at the end we would be just returning count. That would be giving me the number of unique elements that are present inside my particular array. And also, if somebody asks you that what are the unique elements that are present inside the array, you would have to just iterate till the count number of values in that particular array, and you would be getting the unique elements that are present inside the array. So let's just go into our PyCharm console and let's try to code this particular solution. And I want to say that this particular solution is better because it does not use that auxiliary space that we were using the previous time. We do not require a special array in this case, so we just need the particular array that we are provided as an input, and we would be changing the values in place only. Okay, so let's go to our PyCharm and let's start coding for this. So let's write our function as def count unique, and let's pass two parameters, int arr and int sorry, there would not be unique, there would not be any int here, so there would be two parameters, that is arr and n. So arr is my list. Now let's keep and n is the length of my list. So let's keep a value as count, which is initialized as 1, because always the first element is a unique one. For now, for the second element we would be starting, so for I in range till n, we would be starting from 1 to n. If array of I is not equal to array of count minus 1, array of count would be equal to array of I. As you had seen before, that if the element in the count minus 1 position is not equal to, I would be just assigning the next value to the value of my current element in the array, and I would be increasing my count by 1, so count plus equal to 1, and we would be returning count. That would be the number of elements that are unique inside that particular array. So if I have my array which is given as 10, 20, 20, 30, 30 and 30, and if I call this particular function, let's print this particular value, count unique, and let's pass arr and the length of arr and let's run our particular code here. So we are getting 3 as our output, that is 10, 20 and 30. Let's remove this particular section and let there be only 30 present in our array. Let's run our code and we are getting 1 as our output. So as you can see that we have successfully coded this particular solution, and we have done it in an order of n in a linear manner only and without using any auxiliary space. So thanks for watching this video, guys. See you in the next one.